Hello and welcome back to the fourth episode of the Active House USA podcast. I'm your host, Saul. I am the marketing coordinator here at Active House USA. I am joined by Active House co-founder David Knight. How you doing, David?
Great, and thanks for having me, Saul.
Great to have you. And today we'll be talking about SpacePak. SpacePak is a manufacturer of a variety of HVAC products. We have two very special guests representing SpacePak. We have Jim Bashford, the National Sales and Training Manager. How you doing, Jim?
Very well. Thanks for the invite today. Looking forward to having a good conversation.
Right. Happy to have you here. And then next we have Zach Liske, who is the founder and president of Flowtech, and he is a manufacturer's representative for SpacePak. How you doing, Zach?
Good. Great to be here. Thanks.
Awesome. So before we jump into everything SpacePak, I first wanted to ask you, Dave, if you can just kind of give an overview of Active House to let the audience know what we're all about.
Sure. Active House is a green building program that stresses, before anything else, true human comfort. Imagine the occupant who's sitting in their house. What do they feel? What do they hear? What do they see? What do they smell? What are their senses? How are they best treated in the built environment? And Active House focuses on those things, as well as efficiency, solar production, and water conservation, a few other things. But it's a very, very logical, very practical program, and something that is gaining great traction in the United States.
Great. Awesome. Well, so now let's jump right into SpacePak. Jim, do you want to just kind of provide an overview of SpacePak real quick?
Yeah, so SpacePak has been a manufacturer located out of Westfield, Massachusetts, owned by a much larger company, Mestech Incorporated, that owns multiple HVAC-related companies and manufacturers around the country and Canada. SpacePak as a company has focused primarily on small duct high velocity air distribution. And about 12 years ago in North America, we introduced air-to-water heat pump technologies, which is where our focus will be today.
Okay.
So from its inception 12 or 13 years ago here, we've really been pushing the envelope, right, as far as technology and efficiencies, and kind of reading the market and doing what we need to do to not only stay ahead, but keep things relatively simple, and that way integration to existing systems and the integration into the HVAC market becomes seamless.
Awesome. And then Zach, did you real quick want to kind of go over your part with SpacePak?
Yeah, we have the pleasure of representing SpacePak here in California, Nevada, and Hawaii for the jobs over there. They're nice to check out sometimes. But yeah, really great to be with a product that is innovative and cutting edge and really exciting, especially here in California, where the policies are trending to really push this type of equipment.
Definitely. And so that's something you could probably speak to more, right, Dave? The policies?
So in California, the energy code, which is known as Title 24, is absolutely stressing, not completely outlawing, but shoving you in that direction of going all electric. So having a system that can provide a very, very efficient way of converting electricity into warm water for space conditioning, warm water for domestic, chilled water for cooling, is really quite amazing. And it's, SpacePak's been the top of the class for many years.
Very cool. And so that's where these air-to-water heat pumps come in. Jim, do you want to kind of give a summary of what an air-to-water heat pump does?
Yeah, so we get this question a lot, right? Generally, when somebody says, oh, you got a heat pump, they specifically or immediately think to an air-to-air type heat pump, or some of the generic, more, on-the-wall type heat pumps. What an air-to-water heat pump is, let's think of it more like a really efficient electric boiler that sits outside. Okay, we have a self-contained unit. Water or water glycol gets pumped to and from the unit for heating, cooling, domestic hot water offset. So the idea is that we can take, we're creating that energy using a much more efficient way, right? Using that air-to-water heat pump outside, taking that energy from the air, creating temperature both hot and cold, and sending it in hydronically, right? So when it comes in the house or the home, the commercial project, anything, using water as a medium, it can really only be limited by one's ability to understand water, right? We can move BTUs a lot more with water than we can with air. We can take them through radiant panels, radiant floor, radiant walls, radiant ceilings, chilled water, chilled beams, water, chilled floors, and things like that in certain areas.
Nice. So you'll just need this one unit to do heating, cooling, and domestic hot water?
That's correct.
Wow.
So there's options depending on how an individual would set it up, where we can handle heating, cooling loads sometimes simultaneously. We're kind of the engine, if you will, that creates that energy, and then the distribution, the designer, the engineer comes into play when it's like decides where we need to send the water, right?
Jim mentioned space savings, and that's one of the things is one of the most powerful parts of hydronic heating is how much space it saves compared to air source systems. I mean, you can move a tremendous amount of heat through a very small pipe, and we define modern architecture in our office as homes without room for conventional ducting. And that's just the first thing that gets tossed in almost any new home is a nice big attic or a nice big crawl space. Everything has to fit, and hydronic heating gives you a million different options.
So I'd imagine architects would love it for that.
Exactly.
David brings up a great point, because you can literally heat and cool a space without even knowing anything's happening, right? There's not that conventional aesthetic grills and plates and panels and things like that, fans and whatnot.
So even on the homeowner end, you're maintaining your aesthetic of your environment. You can do a lot of cool stuff.
A lot of time what it comes down to is that aesthetics. How do you feel, right? You want to feel comfort, right? And that's really what it comes down to.
Very cool.
They don't want to see it. They want to feel it.
So I guess that can kind of segue into a comparison, compared to these standard traditional systems you see in the majority of homes. How does like a hydronic system compare?
Well, the biggest single advantage is its flexibility, because we can put in radiant floor heating or radiant ceiling space conditioning for the ultimate comfort and obviously the least amount of space utilized. And so that's the single biggest advantage. I would say that's, at least to me. So many people, when they're, what radiant gives you is this silent, invisible level of comfort that just cannot be matched with an air system. It just can't, especially if you have cold surface floors, tile or hardwood. It's unsurpassed. So that's the first big advantage. And then, as Jim pointed out, we're producing chilled water too. We can, through radiant ceilings, we can give, radiant cooling through the ceiling, or we can go to fan convectors or fan coils and provide more conventional sources of cooling. And at the same time, this one device is also very, very efficiently producing your domestic hot water.
Awesome. And so how does that actually compare to these systems in terms of like refrigerant? I know, hydronics is a water-based system. Sometimes glycol is added into the mix, but you're avoiding all this refrigerant, right?
You're avoiding a lot of the refrigerant, right? Not only are you avoiding the large amount of refrigerant, you're avoiding the high-pressure refrigerant lines traveling throughout the houses going to these different ducted type systems, right? We've transitioned all of that refrigerant, which is in a much more reduced amount, to an outside unit. Nothing traveling inside except for something we're very comfortable dealing with, the water glycol mixture. And from there, that's where the magic can happen.
So that's a human comfort too. On the inside of the house, do you really want to have refrigerant piped into your house? And I know, at least locally here in our market, that the utilities and policy people really want to reduce that amount of refrigerant. I didn't know this before I started in the industry, but refrigerant leakage is actually a contributor of global warming, so just a big contributor. So keeping that down, keeping it in that outside appliance, technically called a monoblock heat pump, air-to-water heat pump, is real important.
Okay, so we say that term monoblock as opposed to, there's something else, right? That's like a split system?
That's correct. Yeah, so think about a monoblock as kind of a self-contained, real sexy-looking unit that sits outside, right?
That's a bit of a stretch, but it's not bad.
It's nice.
If you're in the industry,
at least it's one unit, right?
Correct. Having that one unit that has the ability, as the ambient temperature and the climate changes, to do multiple functions, with the correct infrastructure inside, it becomes incredibly flexible.
Very cool. And then you're also, in terms of GWP, Dave, do you want to kind of explain that? So, less refrigerant, less output in terms of global warming potential?
I don't know anything about that.
Oh, okay.
Well, I know that in California, they're coming out with, GWP refrigerant restrictions where they want less of it in systems. They also want different kinds, so it has less of an impact on the global warming potential. So we're seeing a trend, and SpacePak's getting ahead of the curve on the R32 refrigerant on there too. But the refrigerant part is a big part. So you're limiting how much it is and then where it's located also.
Very cool. Do you want to tell us a little bit more about the market in California and kind of what you're seeing here?
Yeah, one of the things that is happening here with everything being mandated for all electric heating, cooling, is the need to kind of shift that demand, right? We don't want to have it on the peak demand in the evening time. So these systems are unique in that being able to produce your BTUs on site, your heating and cooling needs, and stored thermal storage, which is your hot water or cold water, and then being able to use those when you need them, which is the evening time and when occupants in the house need them. So that's called load shifting, and that really helps with utilities to spread out that load on the infrastructure.
Okay, and so
Let me just jump in there because it's actually a bigger story. The way California's solar net metering has recently changed, and so it's become critical for the solar that you produce. You have to consume it on site, and it's very the solar is being produced between 10 and 4. Well, there's a very good chance you don't need it between 10 and 4, so you have to store it. And you have two basic options: chemical storage, which is batteries, which is fine, or thermal storage, which tends to be very, very low cost compared to chemical storage. And given these given the fact that Californians have to put in solar in any new project, but there's no value to it unless you're consuming it on site. You have to store it. The thermal storage is by far the most cost-effective way of doing it. And the best part is that our electric rates, we have time of use electric rates, and our electric rates are up to 63 cents a kilowatt hour in the summertime between 4 p.m. and 10 p.m. So the idea is our air-to-water heat pump produces nice chilled water during the day, and then from 4 to 6, we're taking that chilled water, cooling the house, eliminating any of those fees. And so the cost effectiveness is really is great. In the wintertime, it's the opposite. We're producing hot water, and then we're heating the house as much as we can from 4 p.m. until whatever.
Gotcha.
So it's a really, really powerful advantage to air-to-water heat pumps.
Definitely.
There's many to kind of speak to that point of how important it is, and California's a big proponent of it. Different areas in the country, we've had firsthand experience with homeowners maybe that have had PV solar since before it was cool, right? And they have large credits and they don't know what to do with them. They think, oh, geez, we'll put in an air-to-water heat pump because it's electric. And but when they couple that and that system is designed appropriately, we've got houses with 900 gallons, 1,000 gallons, 2,000 gallons of storage. With as efficient as these units are, right? 2 COP up to 8 COP during their runtime, they're most efficient at 2 separate times, right? And that's when they're on and when they're off. So we want to optimize those times. Companies like Green Mountain Power is a power provider in Vermont. They do an off-peak and load shifting price change, right? So we've got very normal residential blue-collar homes that are designing with 1,000 gallons of storage, 500 gallons of storage. And when their house is designed to heat at already a low temperature, or they're a very efficient house and they're designed to cool at a slightly warmer chilled water temperature, that thermal storage goes much, much further.
Gotcha. And hey, you mentioned that term COP. I'd love if you can just kind of go over what that means for maybe people who don't know.
So COP, or coefficient of performance. So generally speaking, in the air to water market, it's been the, I guess, most understood term of efficiency. I kind of try to simplify it as much as I can so that I can also understand it better. I think of a COP as $1, right? Or when something has a COP of 1, it's 100% efficient, whether that be electric resistance baseboard, an electric resistance element in a water heater, perhaps. Anytime you get something above 1, you actually get a return. So if I gave Zach $1 for heat or cooling and he gave me $1 worth of that energy back, that's a 1 COP. If I give him $1 worth of something and he gives me a much higher return, a 1.5, a 2, a 3, a 4, I'm getting that much more return. So There are points when these systems are designed appropriately for not just the house, the water temperatures, the emitters, the distribution, the hydronic distribution, the heating, the cooling, the radiant style technology, where they systems really become ultra efficient.
What sort of COP? I mean, California design temperatures, low 30s, average winter temperature 50. Yeah. Our COPs are going to be...
Yeah, our COPs are looking 3 to 5 probably on a pretty regular
If we had a nice low temperature radiant, it's probably closer to 5.
And then that's correct. It's interesting to look at the heat pump water heaters that are so common and popular now. And when you actually provide domestic with air-to-water heat pump like SpacePak, those COPs get really, really high because you're capturing all that outdoor heat, and injecting that into the domestic water. Wow. Up into the 5s and 7s, I think, on the
Yeah, and that again goes back to the active house principles of you start with a very efficient thermal envelope, you put in the most comfortable type of system, which is radiant, which happens to be a very, very low water temperature needed, which makes our COP that much higher. Again, we have the option of the flexibility of storing the energy with some thermal. 1,000 gallons for a California house is probably a little hot. Yeah, I understand.
You have big houses here.
We have big houses, yeah. But it really does make for a nice, logical, cost-effective way of providing a safe, comfortable house.
You speak to the envelope, and I'll tell you, I get to travel all over the country and Canada and everywhere else. envelope is really key, right? I kind of make the joke that, without the envelope of the house, a good envelope can make any system, okay, be efficient, right? But I'm obviously partial to our piece of equipment, right? Our pieces, our offering of equipment are the best in the business, coupled with a good envelope. That's where the magic happens. That's where the efficiency comes in, and long-term savings and efficiency.
Very nice. And so in terms of your market, are most of your projects new constructions that you're seeing, or are there some?
I will tell you that the percentages off the top of my head, I don't know, but there's an immensely growing market of retrofit applications.
It's great to hear.
Okay. Houses over the years that have been updated or starting to adopt some of the ideas of more efficiency, better windows, aesthetics, and things like that. And all of a sudden, those previous homes with previously high BTU loads, they start to drop. Okay. And once they start to drop, then they could start to utilize some of this more high efficiency equipment.
Okay.
So it's one of our focuses too here in California is what we call mass market hydronics, which is utilizing an air-to-water heat pump, tying it into a conventional forced air system and utilizing the fan on that forced air system, but turning the gas off.
Yeah, there's a market we refer to as electrofit, which is California's got 13 million existing homes. Almost all of them are dual fuel. They've got gas for space heating, domestic hot water, and many Californians are choosing to turn off the gas, go to high efficiency heat pump equipment for space conditioning and domestic hot water, all produced by unbelievably inexpensive compared to our solar electric is incredibly inexpensive compared to the cost of our grid. And so it makes environmental sense, but most importantly, and for long-term growth, it makes economic sense. And we can almost always prove that.
Gotcha. And in these retrofits, since hydronics is so flexible, you guys can tie into these pre-existing like radiant floors, for example, if they're already using, with already a hydronic radiant floor, using a boiler.
Yeah, my day job is at a mechanical engineering company, and I think we've got, half a dozen jobs that we designed 20, 25 years ago using gas boilers, and for whatever reason, the owners are switching to heat pumps. And more often than not, we can make that retrofit easily. And a big part of the reason they're doing it is because they have enough solar to zero out their bill. So it makes good long-term economic sense.
Yeah, way worth it for them.
And as long as we're within the range of delivered water temperatures required for that home, and the more efficient homes get, the lower the water temperature that's required, right? The lower the water temperature required, the more efficient the equipment is as well. And we offer equipment that's designed heating, cooling, both cold climate, warmer climate equipment.
Yeah, it's like, again, Active House, big proponents of radiant heating. And there's a couple different ways of putting radiant heating in. And the way that works best is anything on top of the subfloor, especially if it's got tile or hardwood floors above it, and especially if it's got an aluminum-based system. One of our Active House sponsors is EcoWarm, which is a really nice product. On the other hand, a lot of people like to put the tubing underneath the subfloor with or without aluminum plates, and that's a much harder, it requires much hotter water, and it's a harder task for an air-to-water heat pump. It's not impossible, but it's much harder.
That's due to that thermal mass difference, correct?
Yeah, just you need 20 to 30 degrees warmer water. Our COP goes down if we can. And the thing about heat pumps, truth be told, the colder it gets, the efficiency goes, the colder it gets outside. Obviously, our heat loads are going up. Our requirement for hotter water and our capacity to do that is lessened. There's ways we can make it up, but they're not as efficient.
Yeah. And so that's a good way to get into the cold climate operation of these heat pumps that SpacePak's offering.
Yep. So all of our current equipment are all variable speed compressors, and some of our cold climate options have EVI, so advanced vapor injection compressors, right? So larger coil surface on the outside units allows us to give high heating capacities at very low ambient temperatures, down into negative 20 and 22 degrees Fahrenheit. So, and still being able to hold on to, 30,000+ BTUs of delivered BTUs at a set 120 or 30 degree water temperature. So the technology has really come leaps and bounds. Some of the benefits of the variable speed compressors is that we're only using the amount of energy we need to, right? Like even when we talk about quiet or noise or what's that unit doing when it's outside, right? Even though we're in the low 50s for ambient decibels, those units are very rarely ever, when designed properly, running at their fullest capacity, right? So they're able to kind of go up and down as the load shifts and changes in the home.
Okay, gotcha. And then these heat pumps you're discussing, how recent were these introduced to the market? Are these more of a new product for you guys?
So SpacePak has had air-to-water heat pumps in North America for about 13 years now. Okay. Most recently, about 3 years ago, we started introducing variable speed air-to-water heat pumps. Okay. So we have a long vested interest in this technology, always searching for the new, right? Trying to stay on the cutting edge. We talked a little bit about refrigerant before, and Zach had mentioned our next transition is into even higher efficiency units using different refrigerants.
Okay.
And that's one thing for me on the rep side is, our job is to go out and train contractors and support engineers. So it's really great to work with, a product that's it's new to a lot of people, and your listeners might be interested in this. Hey, it's brand new type of a technology. SpacePak's been at it a long time. There's a robust network of trained and certified contractors and distributors who can support the product. So that's what we do here locally, and definitely a leader in that in our world.
Yeah, and I can speak to my engineering company's done about 9,000 radiant systems. 8,900, well, let's call it 8,500 of those were gas boilers, and it's been, and again, Zach has done a really, really good job of retraining the plumbers and hydronic contractors, and they're not an easy audience. I mean, they've been brought kicking and screaming into using air-to-water heat pumps, but it's completely turned. I mean, you can only get hit on the head so many times before they figured out, oh, wow, we have to take this seriously. And the best part of that, not only are they installing the systems well, but it's much more competitive. One of the hard parts of hydronic heating and cooling is it was artificially high in cost because the contractors, it was new to them. They kept looking at us like we were strangers, like, why in the world would you do this? Well, there's 10 great reasons to do it. And yet they'd say, well, we'll double our cost because...
Right. We have to keep in mind there's nothing more expensive than labor, especially when someone's not comfortable installing the system.
Which
right?
is another advantage of these units too, is that because they're hydronic based, that you're not needing to have the refrigerant license. So it's easier to go out and get a guy retrained on adding cooling to their repertoire that they're using. It's basically water flowing, water glycol.
Gotcha. Okay, very cool.
And again, let me go back to what Zach has done, because I've been in this market for a long time. No one else was doing that. No one else was training contractors. And they're still not. And there's other competitors, but they're not providing the infrastructure so that an engineering company or an architect or even a homeowner can sit there and go, oh, I feel comfortable that we have skilled, good subs to install the system. And that's completely trained. And that's thanks to Zach.
Yeah,
and a whole network, right? Nationwide. That's what Jim does, is get those guys in place.
Yeah, we have, as Zach mentioned it earlier, a very comprehensive, contractor base. Basically, it kind of grows by the week, right? We have different agencies across the country that are educating people, but without that, without the comfort of that, any kind of idea, regardless of how efficient it is, it doesn't grow.
Yeah. Okay. And so, thanks to you guys, we're seeing the growth of hydronics in America, but that kind of segues into the rest of the world. We're pretty behind the curve, right?
Far behind.
Oh man.
The way I kind of look at it is, when we look at let's say the market of air to water in North America, it's percent compared to other countries, right? And Europe especially. So when we start looking at things as a system, who doesn't want to look at savings, right? We want to save energy. We want to use less energy. We want to be more economical. That will eventually, I believe, get us a little bigger piece of the pie, because you have to show it. The best way to get people interested is quite certainly to take care of their wallet, right, or their purse, right? Take care of that hard-earned dollar, right? If we can use that more efficiently and they can really maintain that level of comfort, then you have a win.
Gotcha.
And the other tailwind on that is policy, right? So global warming requirements from state and local utilities and programs are going to really drive that. The less refrigerant in systems, it's going to drive more to these type of equipment for mass market applications.
Gotcha. Very cool. All right. So now I'd like to get into the market in the United States. Jim, where have you been seeing these units being installed?
So our largest markets currently for air-to-water heat pump, pretty much everything on the West Coast, okay, for sure. And the further north we get as our technology advances and folks get a little bit more used to the technology, cold climate has really been growing quickly, right? Because it's if you're in a cold climate, not only do you need cold, but that means or heat, you need more of it. So it's a little bit easier transition when there is a considerable cost savings associated with that, right? And efficiency savings. So if I need a lot of heat and I can get a lot of heat by doing it this way at a lower price point after install, then that's the way we're gonna look at it. So being able to cover a wide range of BTU loads, whether it's one unit, multiple units. SpacePak even has a commercial size air to water heat pump, 15 tons plus, where we use in light commercial and larger commercial situations. We kind of have all of those bases covered.
Cool.
Yeah, we've got some projects in Lake Tahoe and Truckee, which sometimes is the coldest city in the United States. Even back east, and houses that are fully heated and cooled in the summer with air to water heat pumps.
Cool. And so that kind of makes me think about the size of these houses. Are you typically doing like a minimum size? Can every house have an air to water heat pump?
So every house can have air to water heat pump, right? And let's think about just like we talked about thermal storage before, right? If a house needs X amount of BTUs, right, and we have X amount of BTUs, let's say stored or being able to be created by our heat pump or in combination with the heat pump in the buffer tank, if that very small house only needs X amount of BTUs and we have the ability to make a lot, right, and that unit is not working very hard to attain that, and that just kind of goes back to keeping the unit off for a longer period of time, right, and just kind of sipping those BTUs off of that buffer tank, that thermal storage, satisfying the load.
Okay, very cool. And so what do the controls look like for this type of thing? Is it all SpacePak specific? You guys have your own controls for this?
We do have our own controls, but one of the benefits to the SpacePak line is simplicity, right? So from the very beginning, we've even gone at 12, 13 years ago, we have started changing out some of the older units that we've had, the previous units, and it very similar installation, right? The same wiring, catch points, landing points, piping things is all very, very similar. So being able to kind of go from one to the other, or using third-party controls, right? Generally, there are controls companies that are interested in using our equipment. They might have their own control strategy. They will go ahead and be able to tie into our equipment, whether it be remotely via Modbus technology or just dry contact technology as well.
One place that's critical is when you're trying to do radiant cooling. I don't know, Dave can talk, but what we see a lot is a new trend for ceiling, radiant ceiling cooled. And when you're doing that, you really need a more sophisticated control strategy like a Masana or something like that. But Dave, do you have comments on that?
I do. We specify the Masana controls on almost all of these jobs just because it does give us a chance to control the domestic hot water, space heating, cooling, perhaps the humidity levels if we are doing radiant ceiling heating and cooling. And sometimes, if we got tile floors, we'll throw some chilled water in there too. For the odd job in a mild climate, or if there's just a ton of direct sunlight hitting that tile floor. But the proper controls is, in the same way with a refrigerant-based system or an air-to-air heat pump, you need the proper controls.
Gotcha. Well, it sounds like SpacePak is all about flexibility then in all regards, whether it be the hydronic terminal that you're ending up at or the control line.
Definitely on that. I've got some jobs where the guy's got a thermostat, single zone, one thermostat goes to the SpacePak, turns it on and off. It can't get simpler than that.
Sure.
Wow.
Yeah, we have installs where if we need heating, there's a light switch and it's in one position. If we need cooling, it's in another position, right? Or we have the Masana control system that can be controlled from anywhere, right?
Wow. Okay. Well, then I guess that goes into the zonability too, another flexible aspect of these hydronic systems, right?
Yep. And if you're in hydronics, if you're moving water, you're really only limited by one's ability or understanding of moving water, right? Whether it's pipe, valves, and fittings at that point, right? We need to move water in a GPM flow at a certain water temperature to carry BTUs. The more water temperature, the more flow of that water temperature, the more BTUs we carry. Flexibility also with water is that if all parts of that home don't need the same water temperature, we don't have to deliver the same water temperature every home, right? We can mix it down to where we specifically deliver the BTUs required for that room. For instance, if we've got maybe it's a fan coil unit, and part of the home is running a warmer water temperature, but maybe this fan coil unit or that radiant floor needs a lower water temperature, we can mix it down to deliver a lower water temperature to a floor so that we don't put too many BTUs into that room. We really match the loads quite nicely that way.
Wow.
So the other thing, just to be clear, these water-based systems, if they leak, and again, like I say, my office has done 9,000 systems, and I think I've been asked, 9,000 times, well, what happens when it leaks? Well, this is a closed loop system. What happens if it leaks? A small amount of slightly heated or slightly chilled water leaks out. It's not a continuous running like if your domestic cold or hot water system breaks.
It's not endless.
It's not endless. It's a couple gallons max.
Yeah, I'm sure homeowners would be wondering that. Another thing I assume they'd wonder would be the acoustic performance of these units that are going to be outside. Are they going to be hearing them much, relative to these, traditional AC units?
Yeah, traditional AC units without variable speed fans or compressors, you hear them come on, you hear them go off. Variable speed equipment, SpacePak equipment, start slow and end slow, right? Only ramping up to the BTUs required.
One's a lawnmower and one is rustling leaves. I mean, the difference between a variable capacity air to water heat pump and an old style, single stage AC unit is just incredible.
I've got a funny story. Sometimes I'll have customers download DB apps on their phone.
Oh, I got one.
And go shoot their fridge at home, and they could say, "Oh, there's 45 decibels," and I say, "Well, that's how loud your SpacePak's going to be outside."
Oh,
so,
wow.
Yeah, it's pretty nice.
And generally speaking, when these units are the loudest, right, which is also ultra quiet, like I said, in the low 50s for decibels, it's when it's literally the hottest or the coldest outside, which for argument is the farthest point from the time they're going to be standing out there trying to listen to it.
Yeah, exactly.
Good point.
Yeah.
I wondered where you were going with that.
Yeah.
Awesome. Hey, well, we're coming up on 30 minutes already. In conclusion, I just kind of wanted to ask Dave, so these key principles that Active House really values, this is touching on several of them, right?
Efficiency, comfort, health, being able to use solar produced electricity, not just to produce the warm and chilled water for the space conditioning and domestic hot water, but also to be able to store it efficiently, cost effectively, to offset the most expensive electricity people will be buying. Now, there's a lot of trends moving towards hydronic heating and cooling, run off air to water heat pumps. When Jim was mentioning the efficiency of coefficient performance and comparing to electric resistance, sure, we're 3, 4, 5 times more efficient than electric resistance. And for California, we haven't been able to use an electric resistance water heater or boilers since 1983. So that's just been a flat out no. And so it doesn't even come into the discussion.
Gotcha. Wow. Okay. Well, to kind of wrap up, one thing I did want to talk about with you, Zach, was the support, from these reps that you can get. I'm sure that's another concern for these homeowners,
Yeah.
You guys have a good network, it seems.
Yeah, I mean, we've definitely done that here. That's our marching orders to, for a lot of people, it's new type of equipment, and we're really retraining the industry, helping retrain the industry to provide cooling where they didn't do before. So it's a market opportunity for hydronic contractors to, hey, I can do cooling now. The other great, support that we provide is for engineer support and architects. SpacePak's got a great program called pre-sales where, architects can get information about, if they don't have a designer, they can get information about the system and what's applicable for their particular project.
Gotcha. Very cool. Do you guys have any other final things that you guys want to mention?
I think we could do a 4-hour podcast.
Yeah, this is good. This is lively.
That was fast. I think we can definitely keep going. Well, awesome. Thank you guys for being here. I really appreciate it.
Appreciate the time. Thank you for the
Thanks,
invitation.
so good job.
Thank you.
Awesome. Have a good one, guys.
Wanna hear you go.